Hi guys, welcome to the video. Well, a common question I get quite often over the internet via email or comments or whatever is how do I get a DFX file into a wing program like DevWing Foam or one of the free programs. And my first answer to most of the people is, do you really need to do that? Because unless you've got some special need, there probably isn't really a need to do that. You can download airfoils and put them into wing programs and create a design, but there may be some occasions when you need to do that, and I'll just show you one occasion here where it might come in handy to do that. So as you can see here, we're looking at my Ranger 1600, which I've been doing FPV with quite a bit just recently. It's actually a blast. I've invested in the DJI stuff, and although it's expensive, I can't get enough of it now. One reason why you might need to do a DFX into a wing program is maybe you can't get hold of a wing. Say you need a replacement wing for this. I know you can still get them for this, but say it's a model that's gone out of production, or you've got a plan, and I'll put an example up. You've got an old plan from years ago. I mean, I've done this once or twice, and you want to get the wing design out of it, so you don't know what airfoil is used, and it's not always a good idea just to see what's used on the full size model, because quite often that doesn't work very well when you scale it down. It's all to do with aerodynamics and Reynolds numbers and stuff like that, which gets a bit heavy. Another reason, which I've also done, is you can create a wing from an STL file, so I'll show you how that's done as well. But on this Ranger here, I thought it'd be a good exercise to see if I could make a longer wing. Now you can buy the 2 meter version, which is called the Ranger 2000, and you can still get that wing, but being a bit of a cheapskate and wanting a challenge, I thought, I'd have a go at making a wing for this. Now it is a little bit challenging for this, because if we go down and have a look in here, I'll just take the wing out, make sure you can see that. Yeah, so as you can see there, the wing has to fit into this shape. So how do we get that shape? So what I've actually done is I've taken a picture of the wing, and I'll put that up for you to have a look at, and then I've traced it in a CAD program. And then what we're going to do with the CAD, once we've got the DFX file, I've developed a program called DXF to DAT, and what you can do with that then is then create the DAT file, which you can use into wing generator programs like DevWing Foam or even DevWing. DevWing's the sort of the balsa version of DevWing Foam, or one of the free G-code generators like DIY RC. That's another good one. So what we'll do when we get back to the workshop, I'll show you how that's done and the software I've developed, and it should do what you want. And what we'll do is, as a test, I'll generate the foam in piece for this airfoil, and we'll see if it fits in there, and that'll be a good test. So I'll catch you back in the workshop. So guys, now we're back from the flying field. What we need to do is get an image of this wing. Now, as I said, there are a couple of other methods you can use, and one, if you're not wanting to replicate this wing, but you want to work from an old plan, then what you can do, and I've got an old plan here, it's for a Mustang, what's called a Razorback, the one before the bubble canopy, and let's sit back on the overhead one. Let's have a look there. Yeah, so what you can see there, we've got the airfoil shape there. Now the magazine this came out, it doesn't tell you what the shape of the airfoil is, because it really doesn't need to, because it's giving you all the shapes to a full size. So if you was building this in the traditional balsa way, I think a lot of them are on the back there. So yeah, you've got your forms there. But say you wanted to use a CNC router or create a foam wing, then what you'd need to do is to get this wing here. So the way to do that would be to take a picture of it, but probably a better way, with it being paper, is that if you've got a scanner, just to put this portion in your scanner, and then it's straight as well. And what's also a good idea as well, is to put some sort of ruler on it to get the size in. So what you could do is just put something like this here on top there to get your size in. You can just drop that in your scanner like that, or take a picture, but you'd have to make sure your picture is very square. So that's something I have done in the past. Keep that, we'll need that in a bit. So right, fold it up out of the way. Now the other thing you can do as well, as I did mention down at the flying field, you could actually make a foam wing. Now this is the wing from my my Grom, which was my last video, which took some launching. It's a very lively animal, and I am building another fuselage for it, believe it or not, but it's just down to pure pilot error. I made a silly mistake. But what I've done with this as well, and I'll show you, I'll put some footage up on the video. Because this is an STL file, the software I use, Fusion 360, and you can use other softwares like FreeCAD, you can bring the ST file in, and then we can get the profile from that. So I've done that as well, and I've actually got, because I thought this wing wouldn't be very strong and it wouldn't last very long, I'll probably need to make another wing, but actually I've gone through 3 fuselages and this is the original's wing, so the wings are pretty strong. So, but that's something else you can do if you want to as well. So basically what we do is we line it up as square as we can, so get it lined up on the lines, and that's where these cutting mats are really handy. And then just double check, the other square is a bit smaller, double check that it's looking reasonably square that way, because we don't want it tipped that way or that way. Yeah, it's not looking too bad. And then what I do as well, I put, how did I do this before? I've already done this one. Yeah, I think I had it a bit hard before, but I put your picture in. And then all I did was use my phone. Yeah. Oh, yeah. All right. Carrot cake on the way. Can't be bad. Right. So all I do then is with my phone, make sure my phone's square. I've actually done this before and I'll show you the pictures from it, but because I've got the computer it's a bit more awkward. Make sure the phone's square and then take a picture. And again, you can line the phone up on the lines there, so you know you've got the phone lined up exactly with the wing, so you're not going to get any skew that way or that way. So that's basically how I've got the picture of the wing. And once we've got the picture of the side profile of the wing, you can take the top profile as well. So as many of you may know, I use DevWing Foam, and it's my favourite program for doing this. It's not the cheapest, but you know, I do a lot of this, and personally I think it's worth the money. But with DevWing Foam, you can actually bring this image in, and then you can get the software to get the plan of the wing as well. So we've got this, which we can't directly put into DevWing Foam or any of the free programs. So what we're going to do then, we're going to get this into Fusion 360 or whatever you prefer. There's a couple of rules we have to follow, which I'll explain later, as to regard the DXF drawing. And then what we'll do then, once we've got that, we'll then put it into the DXF to DAT program I've developed, and then we can get it into our favourite wing generator program. So what we'll do now is I'll show you the image and what we do on Fusion 360. So in this section, guys, we'll show you how we go from the image to get the actual DFX file out, which we can then use in the utility that I've developed, DXF to DAT. And there's a couple of little extra steps after we've got the file out of Fusion, the DFX file, that I'll show you. So what we'll do, I'll just go through and explain what we're doing here. So I've got Fusion 360 here. Now, I think I might have said earlier that Fusion 360 is free for hobbyist and personal use, and it's the one I use the most. It's you know, a lot of people say they prefer other software, which is fine, and I think you can probably do the same with other software. So long as you follow this process to get your DFX file out, then, you know, other software should be fine to do this. But I've just got used to using this, and, you know, when you're getting a bit longer in the tooth like I am, you stick to what you know best. So what we do first of all, I've fired up Fusion 360, and what I've done just off camera, I've saved the file. The reason for saving is once you save, it then captures the history down at the bottom. So if you make a bit of a boob, you can go back into the history, find when you've gone wrong and change it, and either delete what you've done afterwards, or it will fix what you've done afterwards. So what we do, the first thing we need to do is import our image. So on Fusion 360, where we go is we go to Insert. So go to Insert, and in Fusion it's called Canvas. So we bring up the canvas, and then I'm going to insert from my computer, and then I'm just going to find my image. If you're like me, you've probably got hundreds of images on your computer, and they take some finding sometimes, even though you do try and organise them, but this isn't too bad. So I've got a folder here called Ranger, and we go into the Ranger, and there's the image there, ranger.gpg. And this is the one I said earlier that I'd captured and with the scale on it to get some idea what it's like. So what we need to do now is tell it where we want to place the image. And I normally place it on the top plane. So we go into the top plane and say OK, and there the images come in. Now it's quite small, and I'm just using the scroll wheel on the mouse to make it bigger. And then what we need to do then is go in and calibrate the image. Now this isn't absolutely necessary for this process, but because I'm going to try and make the spars and that, I like to know what the sizes are, and this is a good way to do it, you know, to get me in the right position. So we go on to 200 there, and on to 100, and you see just before that I did select calibrate on the image. And then when it comes up with the blocks there, just put in what the measurement should be. So that should be 100 millimeters. And then you see now it's because it was 7 millimeters, it's gone to 100. It's a hell of a lot bigger. So we just get that down to size. And now what we can do now is we can go and create a sketch. And we're going to create it on this top plane here, same as the image. And the first thing I like to do, I like to create a construction line. So on Fusion 360, we go over to the line type. I'm just getting it sort of zoomed into where I want it. So select the construction line. And I like to put a straight line across where I think the sort of the middle of the airfoil is. And you see, to start with, I don't actually get it spot on to start with, but we can adjust that in a little bit. So I've clicked a point there, we drag it to there, and make sure it says 0 degrees in the dimension box there, so we know it's straight. And just pull it out. It doesn't matter how far you pull it out, just pull it out a bit. And we say OK to that. Now what I'm going to do now is, as you can see towards the back, it's looking a bit high. So what I'm going to do is I'm just going to move this down. So I've clicked on the construction line and right click, and we get move copy. Now you can move it with the arrows, but it's usually a bit coarse. I think it defaults to 5 millimeters. So if I try moving it down a bit, you'll see in the Y distance it goes -5, which is a bit too far. So what we can do is we can just go into the Y distance there and type the actual value we want. And I think I ended up at about 2.5. When it goes red there, it means you've got now it's not absolutely dead level with the wing, but what we'll do later, once we've got the DFX out, we'll use a program called XFLR to straighten the image up for us. It's a lot easier to do it like that, I found. So what we're going to do now, we're going to now create the splines. And as I've said in this before, guys, you can only create 2 splines. If you create any more, the utility will fail. And what you need to do is don't create loads of points, because you'll end up with a very funny looking fuse line with lots of little steps in it. So all I do is create one point near where the sort of the most curve is, and I sort of bring it down to somewhere around here. So you can see that line there extended to construction line. And all we do now is we move these handles, they're called tangent handles, and we can move them. And as you can see, it's altering the shape of the curve. Now this bit can take some time to get right, and you can, I end up playing about with it quite a bit. And for this demonstration, I didn't go into too much detail because it would make the video too long. So basically what I'm doing is just lining it up as best I can to the image to get the profile, and then going to the front we've got this tangent handle again, and you can see as you move one it does tend to alter the others as well. So it's like a iterative process. You keep going back and tweaking one, and you can also move the points as well. So I've only got one point. Sometimes moving that point helps as well. So just take a little while to get to the best out of this. Then what we do now is we go and create the second spline, and we just pull it out to where we want it. The reason we're pulling it right out is we can't create an airfoil that's like we've got here, where there's just a step in a straight bit in the back. So that wouldn't work very well. And when we get it into the foam cutting program, we can actually create that there with the foam cutting program. So what I'm going to do now is going to go and create a constraint, a tangent constraint on the front of the airfoil there, on them two splines. Now if you don't do that, you'll end up with like a very pointed join there, but by putting a tangent in it, make sure it's nice and smooth. And then I'm just adjusting the sketch point to get the best sort of fit as I can. So do take your time with this as well to get it the best you can. I mean, sometimes I can spend a good half an hour or so trying to get this just right, but for the purpose of this video, I'm not going to take too long. Now what we do now, we want these two to join, and as you can see there, I've gone on and pressed the extension, and that's extended the spline to meet the other spline, and we've got a cross there. So I've decided I wasn't too happy with that, so I've just gone up and decided to tweak the tangent handles again a little bit. Now that's looking quite good now. Right, so what we do now is we go up to right, so I'm fairly happy with that now. Now we go up to extend, which is the little arrow icon up there. There we go. And we'll extend that one, and you can see that red line is going to meet the other one. And don't worry about the warnings about constraints, because you know, for this process we're not too worried about the constraints, just a tangent constraint at the beginning. And then what we do now is we use the trim function and cut those excess bits off, and then again we get the constraint one. So now we've got the shape of an airfoil that comes to a nice point, which we can use now. So now we've got that, I'm going to delete the construction line because we don't need that now, because that will come through in their DFX, which we don't want. And what we do then, we then save as a DXF file. So as I said before, just double check that you've only got 2 splines, because if you've got more than 2 splines it won't work. I'll only have a couple of control points as we've got on here. So right click on the sketch, save as DXF, and then we go into the dialog and then type in a name. And there we go, save. So that's our DXF created. So what we'll do now, guys, is we'll go on to the actual utility that I've written, DXF to DAT, and I'll show you how that works. It's quite simple, and you know, we should get our DAT file out with no issues. So I'll see you in the next section. So right, guys, in this section we're going to see how we create the DAT file from the DXF that we've just created in Fusion 360 or whatever, you know, CAD package of your choice. And we've also got this other program on here which I've installed, which is called XF LR5, which it's not strictly necessary to use it, but I find it does tend to tidy the airfoil up a little bit as well, you know. So you'll see what I mean by when we go into that. Right, so first thing we need to do is from the website download and install the program. Right, so if you're on DFX to DAT, and it's a very simple program, although there's a lot behind it. The interface is very simple. We select the DFX that we want to convert, and we go down to that one we created earlier. There we are, Ranger Airfoil DXF. We go to open, and if there's no problems, it will come up with conversion successful. Now, if you've not followed the rules of creating the program, you'll get an error here, and it will tell you what the error is. So you know, if you've created it with 2 splines, like I've said, then it will work fine. So we get conversion successful, and what it will actually do, it will create the DAT file with exactly the same name as the airfoil, but with a .dat extension. So if we come off that, and in the directory where you got where you stored your DXF file. So if we come off that and we go to, I've got mine in code. Python, Xfoil, and then we just sort it by. There we are. We've got, so there's the file we just created, Ranger Airfoil.dat. So if everything goes well, that's what you should end up with. And if we just open it up with Notepad to have a look at it, and as you can see, these are all the coordinates for the airfoil. So I've seen quite a few programs, guide that, as I might have said earlier, that will take one of these and turns it into a DFX, but I haven't personally found any myself that do it the other way around. Now, the old Profili Pro 2 did that. It would take a DXF and then create a DAT file from it, if you've got that. But if you haven't got that, this is what you can use. So we'll close that down now. And what I like to do now is use this XFLR5 program. Now this is quite a complicated program, but we only use a tiny bit of it, so don't worry too much about it. So it starts up, and all we've got to do is select module at the top, and what we're going to do is go for direct foil design. So we pick that, and then on the little open file folder icon there, we go open, and then we select our airfoil that we've just created, and there's our airfoil there, and it shows down here. Now this one here is spline 4, that's in by default, and I've got it clicked off the moment, but if you just click that on, that's just a plain symmetrical airfoil, I think. So we're not dealing with that one. So what I like to do now is go onto the Ranger Airfoil. If we right click on the mouse, we get this option here, derotate. So, and what that does, if we haven't got this end here quite lined up with the front, you'll see it in a minute. I mean, it's not far off, but if we do derotate, and it asks a few new names, so we'll call it Ranger Airfoil. Let's call it straight. And if we zoom in if we zoom in with the mouse, you can see, go at the front here. Yeah, it's not done very much, but you can probably see just around the back here. Yeah, it's just like that. But it does, if you haven't got it quite straight, then this will sort it out for you. And the other thing I like to do is go on to normalize the foil. And this tends to tidy up all the parameters as well. So if we do that, and there we are, we've got a real good airfoil. So all we have to do now is right click and then export. So there we are, Ranger Airfoil straight that. And all I do is save that in the same folder. So we save that, and that's it. And that's all we need to use for Xfoil, XLFR. I think basically it's, if you've ever used Xfoil program, guys, it's a command-based program. It's really good, but it does take some understanding. And I think basically what this does, it uses that sort of technology, but in a friendlier manner. Right, so we come out of that now. We don't need to save this. So now we've done that, let's see if this will actually work in one of our wing programs. So I'm going to show you DevWing Foam 2, and I'll show you one of the free ones as well to show it works on the free ones as well. So we'll open up DevWing Foam 2. Where have I got it? Somewhere on here. There we go. And I think I've already created I've created one here called Ranger YT, which is this one, Ranger here. This was the one I actually used when you see the cutting job a bit later. So, but we do this just to show you so go modify selected, DevWing Foam 2, although guys, it's not a free program, it's a fantastic program. I don't use anything else. Right, so what we've got here is the this thick part of the wing on the Ranger, and this is what we're going to attempt to make. So I've already cut this out already, so this is what we're going to make. This first little section on the Ranger wing, which I showed you earlier. And so we go on to the next couple of pages there. Now this is where we can insert the airfoil. So I've already got one here, I've called it Ranger Flat, but let's import our one that we've just done. So there's two ways you can do it. You can select a DAT file, or you can actually import it. So what I'm going to do, I'm just going to select it, and it's going to ask me where it is. So I've just got to navigate to where it is. So it was in Documents, Code, Python, Xfoil, date modify. There we go. Ranger Airfoil straight.dat. So open that up, and it's selected it all already. So if we do a 3D preview, and we can go onto the bottom as well. One of the beauties of DevWing Foam, you can have a different airfoil for the root and tip, which is quite handy for some models. So we'll go back to that again, bring that in, and then we can do a 3D preview. And so there's the airfoil we've just created. And then what I'll do is later on in the before we get into the cutting job, I'll show you how I created all these sections here. That was the reason for putting the scale on, to measure it so we could get the positions of these, and actually it took me a few attempts to get them right, as you'll see later. So that's created our airfoil in a DAT format that we can now use. So what we'll do now, guys, is we'll go on to the actual generating this, and then put it on the foam cutter and show you it being cut out. Oh, just before we do that, I did say I'd show you one of the free ones. So let me cancel that. Let's go another good one. some of you guys I know use is DIY RC wings. There we go. Now, this is quite a good one as well. So, and this is all online. You know, a few guys use this as well. It's not got all the bells and whistles of the DevWing Foam, but if you're just getting started, it's a good one to start off with until you need all the extra facilities. So if we select Airfoil, and now we can go to that X foil. There we go. There, range Airfoil straight .dat. Open and see that's brought it in no problem at all. The wingtip, we can either use the same, so that's got the same, and then we just go through the normal processes to create our wing. So it just shows you it works on the free programs as well. So that's how we've got our DAT file from our DXF file. So in the next section we'll show you how we create this, and we'll go on and actually cut it. Right, CNC Foam, DevWing Foam 2. So I'm starting up DevWing Foam. Already got CNC Foam running. And this is my file here, Ranger. If we go into it, just take you quickly through it. So this is just the piece that I said we were going to make to see if it fits in okay, and we'll probably use. With DevWing Foam, you can either just select the DAT file or you can import it. So I just selected it. So this is the one we created, and if we do a preview, there it is, that's the one we created. And we just go through the settings. I put a little bit on sheeting, 0.25, just to allow for some covering. I'll probably do my favourite method, as you may have seen before, which is brown paper and PVA white glue, which makes a really strong wing. So if we look at the side view, you can see there's just a tiny bit there. And then we go into, I haven't put a leading edge on, but I have done the trailing edge. So if we look at the side view, you can see the trailing edge there. I mean, that's because of the way the airfoil is from the picture. And I'll just put a picture back up so you can see it again. So it doesn't come to a point, it comes to this trailing edge here, and that's why we had to make the airfoil extended in Fusion 360, you know, once we got the image in. So then I've gone on to replicate the holes in the side. So here, this square hole here is for the where the spar goes through, and again I'll show you a picture of that. And this is the red area here is the wing clip. So I just went into them, I measured it up on the, and then you can see we've got the measurements there. Go on the side view again. Side view, where we are. So there's the side view again, and then you can there's loads of things here you can alter in DevWing Foam. You know, that's why it's one of my favourite programs. You could just do anything with it. The free ones are okay, but they're nowhere near as comprehensive as this. So we did the spar as well. I'll do a side view of that. So there's the spar. The reason it's greyed out is because it's called a phantom spar. If we didn't have it as a phantom spar, it would go all the way down to the bottom. So if I did it like that and update preview, you can see it takes all that out, which we don't want. So it's called a phantom spar. And then, and that's basically it, nothing else. Oh yes, I did the trailing edge as well. That was trailing edge. Yes, we've done the trailing edge already, I think, have we? I haven't put any lightning blocks in yet, but in the main wing I will. We don't need any of that. Custom ribs, we don't need any of that. So what we do now is we just go to last, which you're on last anyway, finish. And then we'll go to create a cutting project. So we just want one of these. So there's our design. Now these things here, I get a lot of questions about it. So these are actually shaping the foam blocks, which is very useful on tapered wings, but not so much on straight pieces. So if we just go into that and go to custom shape cuts and tell it do not cut. Okay. Okay to that. And see they're gone now. So then we go on to the next one. We don't need to change much on here because this is quite a simple piece, and you can see how it's going to cut. It will do this trailing edge first, it will come round the top, come round here, then it will go up and do the spar, and then round here. This is for this is for actually running the job. So if there's any issues, you'll get a warning here if you've not got enough travel, but being it's fairly, this is just a straight piece, we shouldn't get any issues. Now this if you're pre-creating the block if you want to, ready to go in. So what you would do is you would cut this and then turn it around. I'll show you in the next page how you would do that, because there's two jobs. So if you have a look at here, it says export main blocks, cutting the main cutting jobs to the final wing blocks. Now the other one here is export the side shape cutting. So that was the one we saw there, but we don't need to do that. So all I'm going to do now is create the right G code and run the selected application. I could create the G code and just save it, but I'll just do it this way for now. So we should drop into CNC Foam. Well, it's probably already done it because I've got it running. There we are. There we are. So it's in there now. So I've got the wire set up, as you can see here. Just give you a bit of a better picture. So we're set up there, and I've got it all lined up ready, and I've got some XPS in here. Now I've been testing with the small, so I've been testing with the white foam, but this needs a bit more heat, so I've changed the settings, and I'm using, I'll just show you down here, I'm using the foam cut CNC. There you go, better there. So at the moment it's just waiting to go, and all I have to do, I'm using the wire manually, so I just flip the wire on and there's the current it's using. So I've been testing on some scrap piece of that XPS, and it's set to 0.8 of an amp, so that should be about right. Let's get you back in position so you can see it. That should do it. And I've just got a couple of weights on the foam here. Now when this is done, this piece should do both sides, because it's not very wide, so I'll just be able to split it down the middle. So what we'll do, we'll have a go with this and see how it goes. There's a possibility I might have too much current, but we'll see. So all I need to do now is press start, and off it goes. And then we'll speed this bit up a bit, guys, because it's not the most interesting bit. Here we are, done. Looking at that, I think I might have the wire slightly hot because the corners are not quite as crisp as they could be, but it will probably be okay. Right, so let's take it off and have a look. I've got the little centerpiece here. Yeah, this is really nice foam, this is. Right, so what I'll do is I'll get the Ranger over and we'll put it on and see how it fits. Right, fingers crossed. Slightly, yeah, it's a bit of a tight fit. But let's have a, doesn't fit too bad there, so there we go. So you can see that the, yes, I think I might just have to redo some of the spars a little bit. I think it's just a little bit too far this way, and possibly the looking down the hole for the 10mm spar, that looks like it might be a little bit as well. So but yeah, that's not too bad. So guys, this wasn't actually the first one I did. I did some testing with some white foam, because this XPS foam is quite expensive now, so I only really use it once I'm sure things are going to be reasonably okay. So let me just stick this back up again. So the very first one I did, let me find that. So this was the very first one, and as you can see, that looks reasonably okay, but I hadn't got any of the cutouts and that in. Then I tried this one, and as you can probably see there, I got the cutouts in the wrong position. So that was just in DevWing Foam. I forgot that all the measurements were taken from the centre of the spar, so I made a bit of a boo-boo there. And then this was the one that fitted exactly, so you can see that fits really well. So because it's a bit softer than XPS, so I think what I need to do, if we compare the both of them, they do look a bit, yeah, not bad actually. Yeah. So what I'm probably going to do, I'm actually going to use this, and I'll probably slice it down the middle, and then this will be, let's get the wing. Yeah. So we have a look at the edge of the wing and get the Ranger out of the way. Right, so we have a look at the edge of the wing there. You can see that this bit is actually thicker than the main wing. So I'm going to have to do some testing for this as well to get that section out. But so this is going to be this section here. And if we look at the side, let me get you a good view of the side. It does look quite good. The only thing with this, it does taper in a little bit. So what we'll probably have to do, and that's because on the Ranger there, that goes in, but we can easily take a little bit out there for that to fit better. But yeah, so yeah, I'm quite pleased with that. So the next stage will be, and I'll do that in the next video because it was already making this video too long. So what we'll do is we'll in the next video we'll make the rest of the wing, and don't think on the Ranger wing there's a curve up at the end, so I don't think I'll be able to do that. So it's probably just going to be straight rather, but it will have the same shape but probably straight. So what we'll do, the wing will be cut square up to here, and then all we'll do is we'll mark the design on, and then just you know, cut that off. So That's looking pretty good. So what I'll do now, guys, I'll just do a summary at the end of the video and tell you where we're going next. So guys, that brings us to the end of the video. So I hope you found that useful utility. Let me know if you have any problems with it. And again, if anyone wants to use it on something like a Mac or Linux with Python, then just let me know and I'll provide the source code for it. But that's just a command line option. That's why I did the Windows version, just to make it a little bit friendlier to use. So I just thought I'd give you a little update on some of the future projects. I know the videos haven't been coming as regular, but for a few reasons. To be honest, they take a lot of work, and it does mean that you don't get time to do much else. So I've sort of not made as many recently. But I've got some interesting things coming up, and I'm not going to put any timeline on any of them, because you do that and it never happens anyway. So as you can see by the picture on the computer here, this is the V-turn by Planeprint, and recently one of the filament manufacturers, Sunlu, reached out to me and asked me if I'd like to try some of their filament, and I thought, well, I do enjoy doing 3D printing on planes. This one particularly appealed to me. I do like flying wings. I don't know why. I just like the simplicity of them, and how well they fly. So I'm going to have a go at this one by Planeprint. So I've already purchased the STL files, and then we'll have a go at printing that, and do a video, and hopefully it goes a little bit better than the Grom. So the other things related to foam coating I've got coming on will be quite interesting. I'm starting to look at this board here. Now this is the MKS Tinybee version 1. This is based on the ESP32 chip, and the thing that I'm trying to get working with this, and I'm having a few little challenges at the moment, is getting it to run the web interface. So using this, we should be able to just use the foam cutter with the web interface without having to have a Windows PC attached to it. We'll be able to do it from anything, even a tablet. So I'm working on that at the moment, having a few little issues, but hopefully I can get around that. The other thing that's coming along as well, this is the big tree SKR Pico, and now I've actually run a couple of tests with this, and it's been amazing. This has got the TMC 2209 drivers, and so there's no need to mess about with any of the dip switches or turning the pots for VREFs and to get the voltage. It's it's all done on that. So and I have run a couple of tests on that, and at one point I didn't think the foam cutter was running. It was that quiet. It was actually running. I thought, what have I done wrong here? So that's coming along soon as well. And the other thing with the ramps board, and even on the MKS, that's the MKS board. I've got the MKS here. So the other thing we've got here is this is the MKS version 2.1. You can just put it up so you can see it. So these two are basically the same thing. There's a few advantages to the MKS. It will run on 24 volts, and it's got easy attachments for external steppers. I mean, I really like them boards. They work really well. But one of the things people sometimes find is they can't get enough power into the wire, and especially with the ramps board, because it's only running, you can only run it on 12 volt. There are some hacks to convert it to 24 volts, but you've got to be fairly au fait with your soldering iron to be able to do that. And with the MKS board, you can go up to 24 volts. But what if you want to go a bit higher? Well, what I've been looking into, and this has come from a guy called Thierry in France, I hope I pronounced it right. He's wanting to use a really thin wire on his bow, and what you'll find is when you use really thin wire, the resistance is high, so you need more voltage. And so I've just purchased one of these, got them off eBay, really cheap, and this will handle up, I think it'll handle up to 30 volts. And what we can do then is we can actually connect this to the ramps board or the MKS onto one of the pins,
and we can drive this external MOSFET. So basically what we've got here, we've got these MOSFETs here onto a board, and even though they look smaller, they'll handle a lot more voltage. And I think they said they handle up to 15 amps as well. So there's two of them in parallel there. So I've been working on that, and we will actually need that for the SP32 board, because there are some problems with driving the MOSFETs through the application. But I have got that working off the external MOSFET anyway. So that's what's coming along. As I said, I can't guarantee when they'll be coming along, but I will attempt to get them out as quick as I can once I've done the testing. As you probably understand, there's a fair bit of testing to do with these to make sure they work correctly, especially the newer boards. I'm fairly confident of the Pico, but I haven't so far. I haven't actually got the Tinybee ESP32 actually hooked up and working yet. It's just been sort of bench testing. So keep a look out for them, guys, and I'll see you in the next video.